You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Beatriz Villarroel. Dr. Villaroel studies astrophysics and astroparticle physics as a Nordic Fellow at Nordica, the Nordic Institute for Theoretical Physics. She has served as the lead on multiple papers, using existing survey data to find examples of exceptional astrophysical transients, including looking for physically impossible effects caused by highly advanced technology.
Beatriz Villarroel, welcome back to the program.
Thank you.
Now, Beatriz, you specialize normally in things that disappear, where you see something in a sky survey or something like that, and then you don't. It just goes away. But in this case, in this particular paper, you detail something that appeared and then disappeared. Can you give us an overview of this photographic plate that you found where something appears and disappears?
So in this particular paper, we were focusing on one particular candidate that we found in the VASCO project. This candidate was found in our 2020 paper, and it turned out that for one of the transients, or like objects that appeared and disappeared like during a brief time, we saw that it wasn't alone. It had company of 8 more objects in the same field of view. And that was very suspicious to us. So we made a study on it, and we wrote a paper on it, and we published this paper, which everyone can read now and comment on and give their ideas on.
Now, with a single photographic plate like this, there is the possibility of a false positive, and that maybe contamination might have been in play, or maybe just bad photographic plate. So how do you go through eliminating the possibilities of contamination with a plate like this?
Well, we have done a lot of different tests. For example, we had to consider a lot of different types of possibilities that could give like false positives. Let's say we were thinking about, could it be some ghost images, but ghost images are usually blurred out. We were thinking about scanning errors, where we had to compare different types of scans of the same plates. We were thinking, could it be some type of double exposures, where a plate has been exposed twice to the different part of the skies, and so on and so on. We tried to test for a lot of different possibilities of false positives. Some things we could rule out, other things we couldn't rule out, but they seemed rather unlikely. And for instance, contamination is something I think we should take as a first option, that somehow the plate has been contaminated or has some type of plate defects. The thing that is complicating it is that these stars, or what are star-like objects, have very star-like brightness profiles, all of them. You look there and they look really star-like, and that is what is so confusing about it. And then one needs to try to identify what type of contamination or defects would cause like 8 or 9 star-like objects on the plate in the same region. Well, we already know by experience that it's usually the most boring explanation that explains an anomaly in the end. However, not always, but we should still try to focus on this first explanation to start with. And we've done a number of tests, and this is where we are right now.
So in other words, if someone sneezes on the photographic plate, it looks a certain way. It doesn't look like a point star-like object, right?
That's true. Actually, sneezes are usually like a little bit more wobbly or elongated or come in different shapes, while these 9 things are very star-like in their brightness profiles. So that's why we wrote with like an explanation that it could be some type of unknown contamination, because that means that it's something, it could be contamination very well. It's just that we haven't managed to pinpoint the source.
That's interesting, because that would, if you were able to identify it, if it's contamination, that's useful in and of itself, because when looking at old photographic plates, one should be aware that this type of contamination can occur. Has anybody seen it in any other plates? Anything quite like this, or is this just totally unique?
No, there are some more plates that have some type of dots, but not exactly the same way. We also list those examples in the paper, in the supplementary information. And those were less luminous, and some of them were related to scanning errors. So I think there are a few more plates that might have this kind of effects. So I don't know if it's the same type of effect or if it's slightly different, because we haven't investigated those plates equally carefully.
Now, if you look at one of these point-like sources, and the 9 of them, are they different brightnesses? I mean, are they all the same, or do they vary in magnitude?
They vary. They vary in intensity and still have star-like brightness profiles.
So what is the time frame here? When this telescope, which I think was Mount Palomar, this telescope re-imaged the same area shortly after and didn't see them a second time. What was the time interval?
So actually, there was an image taken on the blue emulsion 30 minutes earlier, where you cannot see the objects. Also, there was an image taken on the same type of emulsion, the red emulsion, 6 days later. And again, you can't see the objects. So it seems like they have appeared within these 30 minutes of like in between the blue and the red filter. Not the red filter, red emulsion, sorry.
Now, these plates, were you able to determine if they were all made at the same time? In other words, did the red plate from one day come from the same batch as the red plate from another day?
We don't know.
So there's sort of that. Now, what's the time frame? Now, people are going to say, well, maybe satellites or something like that. What's the time frame in which this survey was taken?
Well, this is actually something that, I mean, if you would have satellites on the sky and use this kind of instrumentation to look at the sky, you might see something like multiple transients. And it wouldn't be anything weird. However, the image is from 1950, so it would be much more exciting if that observation were true. Because in 1950, that's 7 years before Sputnik 1, and certainly one hadn't launched any satellite that high as to reach a geosynchronous orbit or wherever you could get this kind of effects.
So in 1950, well before, as you say, Sputnik or any satellites, we see 8 objects appear in one plate that weren't there before and aren't there since. Have you looked with more modern methods to see if these candidates are actually out there? I mean, do you have corresponding candidates for these stars that did that?
Well, we tried to look with the GTC, a very big telescope at Canary Islands. It's a 10.4 meter telescope. And we tried to get really deep images to see if there are some counterparts. Well, some of them might have counterparts, but statistically it could just be a background object. So it might be completely unrelated. So we haven't managed to confirm that it's any kind of, that the object is related to our transient. We have also searched for them in all modern archives, and we haven't found anything. So, of course, if it would be something similar to a satellite glint, you're not going to see anything there, because that would be a very short thing of maybe half a second.
What about detections of something like a cosmic ray or something like that? Have you been able to eliminate those as potential candidates?
Well, cosmic rays are not a problem for photographic plates the same way as on a CCD. And for example, if these photographic plates would be sensitive to cosmic rays, they would be entirely full of them, because these plates have been probably in storage for maybe months or even years before they are used.
So now, what about something else that was going on at the time? Nuclear testing. Is it possible that some particle from a nuclear test, I mean, California is not that far from Nevada, so is that an option where maybe contamination from nuclear testing might have set off the plate?
We are speculating on that, actually. Like, one of our main hypotheses is that maybe that could be the case, because we have these kind of star-like brightness profiles. And there was some paper by Webb, I forgot the first name of the author, that showed that when the Trinity test was when it happened, it left rather star-like images on X-ray film. So maybe it could actually be the explanation. However, we're still wondering if it's not, whether it's compatible with that we see more of these objects restricted field of view.
And it also has to be said that I think the majority of the fallout from the testing went the opposite direction. It went east as opposed to west, so you might not have the contamination there at Mount Palomar that you might, in, say, Illinois or something like that. So what would this imply? So is there a technosignature possibility here?
So let me answer this question. At this moment, with the observation that has been done, I wouldn't be interpreting any technosignature because it could be some type of contamination. However, there is a fantastic opportunity here that I never thought about until we got this paper and the results. And that is that there is actually one signature that one could search for in the POS1 plate that would not be confusable with contamination. And that is if you would find this kind of multiple glints along a line, because that would be something very, very typical of satellites or of space debris or whatever. And this is something that we can get as a side result of our general VASCO project, because we generally look for these transients. And now the only thing we need to do is to add a routine to look at, search for objects where you have many of them following a line. Because if you have that, you have something that would not be confusable with contamination, and you would have a very clear technosignature of something that is at geosynchronous orbits or higher, and that shouldn't be there in 1950. So it's a super easy way for us, given that we already have done most of this work, to test for artifacts in the solar system and do this on a very short timescale of a few months.
So this would be something that gets into recent work and the Galileo Project and all that, where maybe something is close and within the solar system, an artifact of some sort within the vicinity of Earth. So is that more likely? So say they're real and there's something to it.
Yeah.
Is it more likely for them to be a close technosignature as opposed to something very, very far away?
I would say so, because that would be the easiest explanation would be that you have some type of pieces of metal, in orbit around Earth in a time when it shouldn't be there. Of course, it doesn't mean that it's ET. It could be something, it would be ET, of course, but it could also be something that has been there since, I don't know, maybe 500,000 years ago, and has stayed there since then. It doesn't mean that there's some UFO looking at us at the moment, but it still could be a very good technosignature. But it would have to be nearby.
But it would have to be nearby. But it also doesn't have to be active.
Exactly.
Right? So it could be some dead piece of something that just happened to show itself, or it could be active, I guess, right?
Well, it could even be something similar to ET's correspondence of Coca-Cola cans that it was left in orbit.
Which an alien Coca-Cola can would be about the most interesting thing we could ever find. Which makes you wonder if we launched a Pepsi bottle into space and an alien civilization found it, at some point in the future, it could be the most important thing they've ever found.
That's possible. Well, I think the most important thing really from the study was that it gave us this idea that we can so easily check for this. We can so easily get upper limits because we are anyway looking for these transients now, and we have these automatized procedures going on, the Citizen Science project. And instead of only looking for vanishing stars, we can add this to our program. And I think that's the most important bit that came out of the paper, the idea.
Now, let's say you establish that stars do indeed appear and disappear, and this is new. And people are immediately going to say, well, before we go with the alien explanation, we need to look at what natural options there are. So do you have a profile of natural options for a disappearing or appearing star? It seems to me that stars are sort of, they don't work on those timescales, maybe with flares or something. Does that have legs? I mean, could we say we're seeing solar flares, brightenings?
Well, solar flares can happen within a few minutes. So if you see something just appearing and disappearing, you can have just a flaring object. And of course, not related to stars, but you can also have afterglows from gamma ray bursts or fast radio bursts. They can be seen in the optical and also be seen like a flash, very short one. The thing about the 9 simultaneous transients is that you have 9 of these things in a very small field of view that doesn't go with any natural explanation that we know of today.
Especially if they're distant, because this would be 9 separate stars, presumably separated by many light years, all doing the same thing at once, right?
Exactly. And if one actually looks at it with this 30 minutes of interval that we have, it's not going to work to place it far away from us. It has to be inside the solar system, whatever is happening.
Or or you get into simulation theory and there was a glitch in the simulation and the stars just simply did that. Do you put much credence in that sort of hypothesis?
Well, I would say it's a speculative idea as many others. Well, any idea that isn't this contamination idea that we're working with on first hand, that is going to be all equally speculative, I guess.
Now, there is an interesting developing, in other words, it's being built, that is probably going to shed a lot of light on your work as far as disappearing stars or appearing stars. The Vera Rubin Observatory, the LSST, what can you do with that kind of all-sky survey imaging?
I would say one can do almost anything if one has access to this wonderful instrumentation. And one of the things that one could do is that instead of doing this manual work we have been doing when looking for something that appears or vanishes, one can do this kind of routines that will automatically search for things that have vanished from the sky or appeared, like pipelines. And then one doesn't need to go back in time and compare catalogs, but you can actually, in the moment when something directly vanishes, you can get some type of alarm and you can directly point a telescope there and see what happened. So the opportunities are great with Vera Rubin telescope.
That's interesting. So you would be able to, so your computer program is looking through the data that it's collecting and it can see something, something changed, something disappeared, and alert you in enough time to post on the astronomer's telegram or something that, hey, everybody needs to look at this portion of the sky, this, these coordinates, and see if this thing is there, right?
Exactly. It's a fantastic improvement if one can use the Vera Rubin telescope.
I'm very excited for it because if you, it's almost a real-time camera, looking at the sky 24/7 or every day and a half or whatever it completes a survey. So this opens up it's the difference between a photographic plate and a video camera looking at the sky. And I think we're going to see amazing things, especially in regards to solar system objects moving. This might discover Planet 9, or it might map asteroids or identify any number of interstellar objects like Oumuamua or Borisov. And it's just going to be a constant flow of amazing things. I don't want to understate how excited I am for the Vera Rubin Observatory.
It's absolutely fantastic project and telescope. So I'm very much looking forward to all the science that is going to come out of it. So I share your excitement.
Now, you are also involved with the Galileo Project. What brought you to join up and consider other possibilities with an artifact study?
Well, I was invited by Avi Loeb to join it, and I was super happy about it. And I still am super happy because this is such a super, super cool work. It's a pioneering project for when it comes to looking for UAPs or like UFOs and looking for solar system artifacts in a very serious way. I think it's a super cool project, simply so. That's why I accepted it. It took me about 2 minutes to think about it until I accepted it, and that's the 2 minutes it took to reply on the email to Avi when he wrote me.
This is a much more all-encompassing search for artifacts in the solar system than, as you said, the UAP. But this opens up ideas like searching collection points in the solar system, that Jupiter has been collecting interstellar objects for 4.5 billion years, and who knows what's there. So this seems to me to be a very efficient way of doing SETI, because you have just the entire product of an immense amount of time just sitting there. So it's almost like, why didn't we think of that first? Because it seems to me to be easier to find that, or maybe find something, or eliminate the possibility as opposed to a transient radio signal, right?
Well, I think it also has the advantage of that people know what they are looking for, that this is going to be about focusing on anomalies on the sky and solar system SETI, or space archaeology, if you prefer to call it this way. And the difference is, like, if you have some other like conventional astronomy surveys, they are focusing on finding things that you already know, let's say supernova or M-dwarf flares or AGN. And then they maybe are filtering away a lot of these anomalies, while the Galileo Project will be collecting all the anomalies instead in real time. So I think it's going to be fantastic. It can only lead to interesting science, in my opinion.
We could find an alien Coca-Cola can, and it would be just a completely new way of doing it, you know, as opposed to radio telescopes.
Exactly.
So, Beatriz, what is the future for searching past sky surveys for transient events? What are you going to do next?
So the closest months, we're actually going to finalize the automated searches the Spanish Virtual Observatory has been conducting for the VASCO project. And we have been then automatically looking for transient in POS1 and POS2. And we have specifically been looking for vanishing star candidates. And this huge search in images probably is going to be done the coming, either by the end of this month or next month. So this is a very exciting thing. And also our citizen science project that has more than 120,000 classifications by now has made lots of progress. So we're going to investigate all the interesting candidates that appear there. And finally, we are going to execute this interesting study where we want to look for solar system artifacts by looking for if we find many transients along a line. This is the things that we're going to do the coming months.
Now, just to envision what that means, so transients along a line. So if you have a rotating object, a metal object that is glinting sunlight, it's going to, in these pre-space age plates, it's going to show blips, right? And they will move in a line, just to make that clear to the audience.
Yeah, sometimes they can leave these kind of traces that you find them along a line. Sometimes they don't, but sometimes they do.
And now doing that using more modern surveys would be a nightmare because there's all kinds of spent rocket stages and all sorts of things that can glint sunlight. So we just have this little window where we can look at old plates before, pristine, before we filled low Earth orbit and everywhere else with objects.
Exactly, that was what is our thought. Because today there are maybe, millions of debris pieces that will be glinting. You can't do it today so easily. While in the POS1 catalog, if you use our image catalog, if you use it, and if you find something, you know already what you're looking at.
Now, the citizen science part, where can people find that and take part?
It's called ML Blink. So it's the web address reads like http://mlblink.org. I will send web address so that people can click on it directly.
There will be links in the description below. Well, thank you, Beatriz, and I will continue to read your papers, and I hope you find really interesting things. This idea of appearing and disappearing stars is novel, but really neat, and who knows what it might tell us about the universe.
Thank you so much.
Thanks for listening. I am futurist and science fiction
John.
author.
Wrong channel.
No, it's not. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently hosting Event Horizon and wondering where Anna actually came from. One day I had a tablet computer, the next I had a boss. Very disturbing, and be sure...
And that's enough of that.
YouTuber forever! Like, subscribe, and hit the bell!
Sell out.
What?